Now let's move on to the final part, where I want to talk a bit about the different applications that we have done in the last 1-2 years, specifically with Macchina. And one that we did just in the last year was a very interesting project in the field of optimization of manufacturing processes. So basically, there was a company that was doing electronics, or it is a company that is doing electronics manufacturing, and they have a production process called matrix production, which is something that was like invented by the German Fraunhofer research agency. And the basic idea behind that is that you have basically a very flexible way to produce things. Your factory basically consists of different manufacturing cells that can be very quickly reconfigured, basically, so that you can use the same manufacturing cell to process different or to produce different products. The problem with that is you now have a situation where you have a factory, and in that factory you have a lot of different products that are in production, basically going from one production cell to the next. And then people working at that production cell basically have to decide, so which product are we going to process next? And it turned out that people at those production cells were not very good at deciding which product to work on next. So they would basically take an arbitrary product that was waiting for processing and process it and then move on. And the problem was the whole manufacturing process became very chaotic, and it was very hard basically to predict when a certain product would be completed in the factory. And so basically the idea was to come up with an AI algorithm that would basically see how the different orders basically would move through the factory from one cell to the next. For that purpose, basically the factory was equipped with a tracking system. So basically for every crate that contains the products of an order, it would have some kind of RFID tag or something similar attached to it. And then there was some hardware basically that was tracking the different crates across the factory, and also a software system to manage that. So basically, the idea then was to plug into this tracking, or to connect to this tracking system, and then try to predict how long a certain product would need to complete basically its manufacturing run, and then give the workers at the station basically a list or a schedule in which they have basically to process the incoming orders. And basically this product was, this algorithm was then built, and the algorithm itself was written in C++. And of course, algorithm alone doesn't do anything. You have to integrate the whole thing into the manufacturing environment. So there were things like the tracking data would be provided over MQTT. There were some REST APIs that we needed to call to get some meta information about the orders and so on. And so basically we decided to do all that with Macchina Edge. And basically what we did was we wrote a couple of JavaScripts that would do all the communication stuff and then feed the data into the AI algorithm. The AI algorithm would then basically for each production cell produce a schedule. The schedule would then be displayed to the workers at the station. And interestingly, that whole product was then deployed and became kind of a huge success, actually. The interesting thing was not just did the production times become shorter and predictable, and the factory was able to complete basically orders in time. Another interesting aspect from a social perspective was very interesting because the factory is actually running 24 hours a day, and there are basically 3 shifts working on each cell. And one of the things that happened in the old or previously was that basically the people in each shift would basically pick out the orders that were the simplest one to process and then work on those. And so basically the people that came after them in the next shift basically had all the complex orders to do, and were of course then a bit grumpy about the workers from the previous shift. And now basically that everyone basically gets a detailed list of what to do in which order, things are running much better. Another interesting project we did in the last 1.5 years was together with a partner again for a company in Israel, and they are basically producing fuel cell based power generators. And these power generators are used in a number of different cases. So, for example, it can be used as an emergency power generator, replacing, for example, the older diesel-based power generation units. And they are also, for example, can be used for electric vehicle chargers to provide backup powers or to provide additional power during peak usage. Or they are also used, for example, as backup power in mobile phone base stations. And the company had a problem. Of course, such a fuel cell is a very complex system, and the fuel cell itself is controlled by a PLC that does all the real-time control and all the things. And then, of course, you need also a higher level system that manages the whole thing and also extracts the data, visualizes the data, and so on. And previously, they used basically an industrial PC for that with some custom written .NET application. And then they also had to integrate with some external sensors. Due to the fact that this was a PC, they couldn't use any cheaper industrial sensors. They had to use more expensive external sensors that had Ethernet interfaces and could be connected to the PC. And then they had some other issues with the whole software. So they decided to basically do something new. And then the idea was basically, instead of using a industrial PC, why not use one of those much cheaper IoT gateways like this one. This is basically an ARM-based computer, kind of similar to a Raspberry Pi, but a bit more industrialized and robust. And the thing also includes a mobile modem, so it can connect to the internet. And then as a framework, basically they used macchina edge. So what this system basically has to do, it has to gather the real-time data that is coming from the PLC, store the data, process the data, and this has to be done in a flexible way. So they wanted to have some flexible rule engine to decide what happens, for example, when a certain data point reaches a certain value or similar situations. And this is basically where the JavaScript support in Macchina came in very handy. So basically what they did is almost the entire thing was implemented in JavaScript. The only thing we did in C++ for that project were some specific protocols. The first one for communication with the PLC, which used a custom protocol. and the other one for integrating domain-specific protocols like DNP3. These are used, for example, in fields like electric grids. There are some custom protocols that are used to integrate these systems into the basically IT systems of an electricity grid provider. And so for that purpose, we used an existing C++ library, integrated that with Macchina, and made it basically also available to JavaScript. Apart from that, the whole system does a number of other things, like it has a very nice web user interface to visualize the data. It's very flexible, so it can easily be used in different variants of the fuel cell device. It can be changed by the technicians that are setting up the systems on site. And the customer has been very happy with that system. One of the things that made the customer very happy was the cost reduction. So instead of basically paying like 3,000 euros per fuel cell generator unit for the industrial PC and all the external sensors, it's now like 300 or 400 euros for the same thing. Yeah, and this, of course, used basically all of the different features that we have in Macchina. So it really was a very interesting project that we did together with the partner. Yeah, and the final thing, also again, industrial application, was done by our partner company, LF1. And this is actually in a steel mill in Spain. They were facing some inefficiencies in their production. They had some problems with communication in their central control system that were causing real troubles and slowing down basically their production process. And so they implemented their own kind of solution on top of Macchina that they then used in the factory to solve the issues. And the result of that was like a 30% increase in production, which is quite a lot. And there are also some other very interesting side effects, like, for example, lower electricity usage. Because, as you all know, as C++ developers, C++ code is very efficient, especially if you compare it to things like Java code or Python code. That easily becomes noticeable because you can do something in C++ with a lot less hardware than would be required, for example, for a Java-based system. This also means they were basically able to run the whole thing on much smaller servers, again, saving a lot of cost, and also with great stability. And this is basically the project, the product that the LF1 guys, which is actually Alex company, the other contributor to the POCO libraries, builds. So at the lower level, basically, they are building on top of Macchina Edge, and then basically they add their own specific features that are targeted towards industrial automation applications. And finally, telematics control units, another huge application area for Macchina Edge. Won't tell you a lot about it, but basically the TCU or telematics control unit is basically the smartphone that is built into every modern car that has been built in the last 5 to 6 years or so. And there are now 12 to 15 million cars basically out there sold by different car brands that have a telematics control unit built in that runs Macchina Edge. Good. And with that, I think since we're already a bit late in the call, I'll just give you a very brief demo, and then we will immediately move to the Q&A part. So as a demo, I will show you something that I did with Macchina for my own home. So in the last
Winter, I think we have finite time, so take your time as a demo.
Yeah. Actually, I built my own house in the last 3 years, and as part of that, of course, I also wanted to do some smart home things, and of course, I had to do this with Macchina Edge, and so I have basically a little demo of what I do. So basically, throughout my home, I have a number of different systems that have IoT capability. So, for example, there is the heating system, the heat pump that I'm using that gives me some data. Then in every room in my home, I have a Bluetooth LE-based sensor, a Rubitech, basically, that measures temperature and humidity. Then I have a weather sensor outside of my house that measures, again, temperature, humidity, and also wind, and a couple of other things. And what I wanted to do is basically collect all the different sensor data, write it into a time series database. In this case, it's InfluxDB, and then create some nice dashboards with Grafana to basically get an overview of what's going on in my house. And so in this case, I have Macchina Edge running as a Docker container on a Synology disk station that's running in my house. And what you see here basically is pretty much the built-in user interface that comes with Macchina Edge. It's not the most modern or most nice user interface, but it gets the job done. Also, the idea is that everything in Macchina Edge basically is implemented as a bundle or as a plugin, if you want to use that word, and can be exchanged by something else. And this you can see here. If you go to the bundles application, you can here see all the different bundles that make up this application, or in this case, Macchina Edge. So you can see here we have, in this case, 112 bundles already. And actually, most of those bundles are part of Macchina. So the only bundles that I added were the different data logger bundles, for example, for the Ruby tags, for another sensor that I have, for the weather station, and also like here for the heating system. And the rest is pretty much basic standard Macchina IO stuff. So what you can do is now, of course, click on a bundle. Maybe use this one, and then you can see meter information like symbolic name, version number, and also dependencies. What you also can do is you can click install and then take a bundle file, for example, from your local hard drive, drag it here, and install a new bundle. And you can also start and stop bundles. So if you go back to the web interface, you can see we have here a number of applications like the sensor log, bundles console, and so on. And each of these applications itself is a bundle. So I can, for example, look for the sensor log bundle, click it, click on stop, and if I go back to the screen, you can see this application is suddenly gone because the bundle was stopped. And then we have the concept of data points, which basically provides abstractions for data that you typically get from different sensors. The whole thing can be organized in a hierarchical way. So I have here my different rooms, for example. Let's take the kitchen maybe. In the kitchen, I have a Ruby tag, and in the Ruby tag, you can see it measures currently a temperature of 24 degrees. The humidity is 54%, and it also measures the air pressure, ambient air pressure, and also it gives me basically the voltage of the internal battery. And then I have a script basically, or different scripts that take all that data from the different APIs and other endpoints that provide the data. For example, the data for the Ruby tags comes over MQTT. I have a Ruby gateway installed, basically that gets the data wirelessly over Bluetooth from all the different sensors and then publishes the data to an MQTT topic. So I have a little script written in JavaScript that basically receives those MQTT messages and then updates the data points and also writes the data into an InfluxDB database. The same happens, for example, for the heating system. In the heating system, it's a bit more complicated because the manufacturer of the heating system does not provide an official API for end users. I solved this in such a way that there are other home automation systems like Home Assistant and so on available. And those have a pretty good community that faces basically the same problems. And so basically some people from that community basically reverse engineered the REST API that is used between the smartphone app that the manufacturer provides. And they have basically implemented that in that case, Python. So basically what I did was I kind of looked at the Python code, found out the endpoints and re-implemented the same here in JavaScript. Which has a bit of challenges because like it happens yesterday, suddenly the system stopped working because apparently with the last upgrade to the app, the manufacturer has changed the API. And so I had like to start this morning a debug session looking at where the specific problem was. Turned out they no longer support a specific feature in the API, so I had to kind of work around that, and now it's working again. You have also things like an overview here of all the different services. You can see with every service that you register, every service basically is implemented as a C++ class. And every service can also have metadata, and this metadata is very handy because sometimes you want to search for a specific service, but you don't know which service or what is the name of the service that you want to call. Say you have like a temperature sensor and you want to read the temperature, and now you can have different kind of temperature sensors. Like you can have one, for example, in this case, the Ruby tag, or you can have the temperature sensor or the temperature value from the heating system. And therefore, we have this abstraction in Macchina Edge that basically gives you the same interface no matter which in which way the specific sensor is implemented. And basically what you can do is then you want to search, if you want to search for temperature sensors, you can basically look for you can basically use a query language that is built into Macchina or specifically the OSP framework and specify you want, for example, a data point that wrong one. A data point basically that gives you the temperature, and then the framework basically will give you all data points for all the temperature sensors. Okay, and as I've mentioned, all the data gets written to InfluxDB time series database, and connected to that is a Grafana instance that's also running locally on the same disk station, and this I use basically for visualizing all the different data. So I have here some data from the heating system. I have data from the different rooms, temperature and humidity, and so on. Good, and with that, I'd like to finish and move on to answering any questions.
Thank you for the nice talk, Winter.